Hello and welcome to Empowered Learning. This particular video will be about permutations and combinations actually applied in application of word problems. And so I'm going to do several examples to show you how we can use permutations and combinations to solve some problems. So let's start with this first example. So it says, in how many ways can a president and vice president be selected from a committee of 32 people? So in reading this question for the first time, you may be enticed to say that this is a committee type problem. And so therefore say that you're going to do the combination of something. But please be aware that this is actually an election problem. Why? Because you see here that we're talking about voting in a president as well as a vice president. And of course, whoever you pick as president, they're going to have a higher rank than the person that you pick as vice president. So order actually matters in how you pick them. So because of that, we know that this particular problem is going to be a permutation and not necessarily a combination as you would think because of this word committee here. So we're going to take out of 32 total people, we're going to select 2 people here. So this will actually end up being the permutation of 32 people selected or grouped 2 at a time. And so when we do that, we know that this is going to be 32 factorial divided by 32 minus 2 quantity factorial. And just as a reminder, we're getting that from this formula here. Okay, so if we keep on going, we see that in the denominator, 32 minus 2 is 30, so that would be 30 factorial. And then from here, we will go on and say 32 times 31 times 30 factorial. And remember, we want to do that because we don't want to write out what 30 factorial actually is. We can just keep it in its compact form. So we have the 30 factorials reducing to 1, and then we just end up with 32 times 31. Okay? And of course, if we come and we multiply that, we will have 32 times 31, and that will give us 992. And so what this is communicating to us is that out of the 32 people, there's 992 different ways where we can pick a president and a vice president. All right, now let's move on to the next example. Okay, so in our next example, we see that we have an organization with 23 members, and they are going to select 7 chairmen with each member having equal authority. And we want to know in how many ways can this be done. The key word to this is saying that they want to select 7 chairmen where each member has equal authority. Okay, so since each member has equal authority here, that means they have the same weight. So each member having equal authority, so they have the same weight. So because of this, we know that this is going to be a committee type problem or combination. Okay, so because of that, we will do the combination of 23 members selected 7 at a time. And so we could either use this notation or we could use this notation for it. But at the end of the day, when we write this out, this will be 23 factorial divided by 7 factorial, and that will be multiplied times 23 minus 7 quantity factorial. So if we keep going, this is 23 factorial divided by 7 factorial times 23 minus 7 is 16 factorial. And so now what we're going to do is, since we know that 23 factorial is larger than both of these factorials in the denominator, we're going to write down 23 to get it closer to 16 factorial. So we'll keep on going here, and we'll say that 23 factorial is 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 factorial. And we have all that. And so we will have our 16 factorial here in the denominator. And I'm going to go ahead and write out the 7 factorial as 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So here our 16 factorials reduced to 1. And now we need to find numbers down here that are going to reduce with numbers up here in the numerator. So if we look, our 7 goes into 21 3 times. We also see that our 6 will go into 18 3 times. We see that our 5 will go into 20 4 times. And we have our 4 goes into 4 1 time. 3 goes into 3 1 time. And now we have just 2 and 1 left. And of course 2, that would go into 22 11 times. So now that we're here, the numbers that we have left are 23 times 11 times 19 times 3 times 17. Okay? So of course, if we go and we calculate all of that, so 23 times 11 times 19 times 3 times 17, and we get 245,157. Okay. Now, we could have also did this directly in the calculator. If you have one of these type of calculators, then you could just punch this in, but you would have to do it in this form. And just to show you how to do that, just in case you don't know how to do that or you've forgotten, here we will press 23, and then here we're going to go to the math button, and then we're going to go into the probability area, PRB. Then we select option 3, and then hit 7, and then enter. And you see we end up with the same thing. So you see we've done this by hand as well as using our resources by using the calculator. And so now we'll move on to the next example. Okay, so our next example says a club consists of 12 men and 15 women. And how many ways can this particular club choose a president, a vice president, a treasurer, and a secretary, along with an advisory committee of 5 people? So if we look closely here, you'll see that we're having to choose a president, vice president, treasurer, and secretary, where order or rank in position actually matters. And then we also have to choose an advisory committee of 5 people where order does not matter. So if you look at this, this is a combination of using a permutation in which order matters, a combination which order does not matter, and the fundamental counting principle as well, because of course you would want to choose the president first, then the vice president, then the treasurer, then the secretary. So we have all those things combined here. So we're going to start off by going from most important rank to least important rank. Okay. So what I'm going to do here is make some spaces, and we'll make a space for the president. Then we make a space for the vice president, make another space for the treasurer, make another space for the secretary. And then after that, we'll come over here and make our 5 spaces for our committee members. So we have president, the VP, treasurer, secretary, and then our committee members. Okay, so since we have 12 men and 15 women, the total that we have is going to be 27. So when we go to select the president, we're going to pick one person out of the whole group of 27. So when we start this, we have 27 choices. Okay. So after we select the president, that's going to go down to 26 choices left. And so then from there, we will go and select our vice president out of the remaining 26. And then that goes away after we select our vice president. And now we have 25 people left. And so we select our treasurer out of those people. And then that goes away. And then for our secretary, we have 24 people left to choose from there. Okay. And so since we're choosing this in order, this is going to follow the fundamental counting principle, and all these numbers are going to be multiplied by each other. Okay. So next, what we're going to do is come up with our way of finding out how many ways we can select the advisory committee. Now, of course, we have to do all of these people, and order doesn't matter, so we're going to multiply. And if you notice here, we have 23 people left now, and we have to put them in groups of 5. So all this is pretty much saying here is that we have the combination of 23 people, the people that are left over, and we want to put them in groups of 5. So if we multiply 27 times 26 times 25 times 24 times the combination of 23 people grouped 5 at a time, we will get our answer. And so for this one, if we go ahead and do all that, I'm just going to do it all in the calculator here, since this will be a rather long calculation there. So let's do 27 times 26 times 25 times 24 times, and now we're going to do the combination of 23 things grouped 5 at a time. So we'll go here to our math button. Oh, sorry, need to go back. We need to first put in our 23 and then go to our math button. Go to probability, select option 3, and then after that, select 5, and then just hit enter. Okay, and so that's given to us in scientific notation. The actual number here, I'm going to go ahead and write out. We have let me go ahead and erase some of this. Get it out of our way here. Okay, so that should be enough. So here, the actual number is going to be 14172588800. So oh, I forgot a 9 here, so there should be a 9 right there. So we'll go back and just erase that. So that means we should have comma there, and we need to have a comma before the 4. And so that's our number here. And so that's actually 14 billion 172 million 958,800. So that's how many different ways we can select the president, vice president, treasurer, secretary, and 5 committee members. A lot of different ways. All right, we'll go ahead and go to our next example. Okay, so our next example deals with personalized license plates. So we have a state that allows personalized license plates with 6 spaces. And these spaces can be filled either with the number 0 through 9, all the letters of the alphabet, or the following 5 symbols. Okay, and you see them there. So what is the total number of personalized license plates that could possibly be made using this particular counting scheme? So first thing that we know before we even get started here is that we have 6 spaces, okay? So we got 1, 2, 3, 4, 5, 6. So after that, we need to figure out how many actual symbols we have. So if you notice, 0 through 9, that's going to give us 10 digits. We have 26 letters in our alphabet. And of course, all this totals out to be 5. Now, the key to making sure that you get this particular problem correct is to realize that with personalized license plates, you could also have a blank as a space, okay? So we have to remember to include the blank. So here, the blank would take up 1 space as well. So for our license plate, when we go to select what we want it to be, of course, we have to make a choice in what we want for the first space, a choice for the second space, a choice for the third, the fourth, the fifth, and the sixth. So since we have to make the choice for the first before the second, and the second before the third, that follows the concept of being a permutation, okay? And so in particular, the fundamental counting principle, which is a form of a permutation. And so if we add up everything, we see that we have our 10 plus 26 plus 5 plus 1, all that ends up being 42. So for our first space, we have 42. Now, if you have a personalized license plate, you can repeat letters. So you could have 42 for the next choice, and then 42 for the next choice, and then 42 for the next choice, 42 for the next choice, and 42 for the next choice. And again, since this is a permutation, using via the fundamental counting principle, we can just multiply all these together, okay? So in essence, we want to know how many license plates we can come up with. We can come up with 42 raised to the 6th power amount, okay? And we'll go to our calculator right quick and calculate that. So 42 raised to the power of 6 gives us this large number here. So we see that it's 548,903,1744. So we do some commas, and we see that there's about almost 5.5 billion of them. So it's a lot of people that will have a personalized license plates before they have to come up with a new system. Okay. All right. And so this concludes this particular example, and we'll move on to the next. So our next example says we have a student and they answer 8 out of 10 questions on an exam. And we want to know how many different ways can the selected 8 questions be answered. Okay. So to start off here, we need to think about this. So we have a student who's taking a 10-question test. And so he answers 8 of them. It doesn't matter what 8 he answers. And since the order of which one he answered really doesn't matter, especially if they're all worth the same amount of points, then that would constitute that this particular situation being something of a combination versus a permutation. Okay, so a permutation would be something like if you took a test to where if you did not answer the first question, then you would not be able to answer the second question, or what you answered on the first question would be directly related to what you would have to do for the second question. Okay, so in this case, you got 10 random questions. You can answer them in any order that you want. So this is a combination type problem. So because of that, makes this real simple. So we have a total of 10 questions, and we need to do combination of 10 questions grouped 8 at a time. So how many different ways could he answer those particular questions? So of course, this is the alternate notation for it. And all we have to do is just use our formula here. So 10 factorial divided by 8 factorial times 10 minus 8 factorial. Of course, we'll break down 10 factorial to the 8 factorial here. So 10 times 9 times 8 factorial. Have 8 factorial there. And of course, 10 minus 8 is 2 factorial. So the 8 factorial is reduced to 1. And of course, 2 factorial is just 2. So we'll go ahead and get rid of that. And we'll just say that 2 goes into 10 5 times. So all we have left is 5 times 9, which ends up giving us 45. So student has 45 different ways that he can answer 8 out of the 10 questions that he did answer. Okay. All right, so let's move on to our final example. Okay, so we have a typical Social Security number, and of course we know it's a 9-digit number, and we want to know how many Social Security numbers can be made up if we are restricting the first 2 digits from being a 0 and the last 2 digits from being a 0 or a 9. So to figure this out, we'll start off by just making up our spaces for our Social Security number. So of course we start off with 3 spaces, and then we have next 2, and then we have the last 4. Okay. So for here, we'll start off and we'll see that each of these, when we fill them in, of course, we're going to be using digits from 0 through 9. So that's going to be a total of 10 digits. Now, if we can't have a, we can't have a 0 in the first 2 digits, so we can't have zeros here. And then for the last 2, we can't have a 0 there, and we can't have a 9 either. Then in our assumption of this, we notice that out of the 10 digits for these 2 spaces, we only have 9 digits left that we can choose from. So if we're choosing a Social Security number, we have to figure out what the first number is first. So we got 9 numbers to choose from there. And then for this one, since we're limited to 0, we have 9 numbers to choose from there as well. Okay. For the last 2, we lose 2 of the 10, so therefore we have only 8 left for the last 2. And of course, for all the others, we have no restrictions here. So we have the full 10 for each of these. Okay, so now that we know that, if we want to figure out the total number of Social Security numbers that we could have with these restrictions here, then all we have to do is just multiply all these numbers together here, okay? And so I'm going to get rid of this last part down here right quick. And so once we're done with that, I'll go ahead and say, all right, so the total number would be 9 squared, since we have two 9s, times 10 to the 1, 2, 3, 4, fifth power, times 8 to the second power, of course. And so now, if we want to make life easy for ourselves, we go ahead and put this in our calculator. So 9 squared is 81 times 10 raised to the fifth power times 8 squared is 64. So we come, and that is our actual number. So as you can see, that is a lot of Social Security numbers, even with those restrictions there. So, yep, it's about 518.4 million people. And so just to kind of give you an idea, the population of the U.S. is roughly around 320 million. So as you see, we almost have, just with those restrictions, you almost have twice as many Social Security numbers as the population. So notice that is a lot. And so this concludes the examples for permutations and combinations, and in particular, applications and word problems. Thank you for tuning in.